Great circle routes on the parallel of latitude. Shortest distance between any 2 points on the parallel of latitude, that is, distance along the great circle of 2 points on the parallel of latitude, is known as great circle routes on the parallel of latitude. Apart from the normal questions on distance along the great circle or along the parallel of latitudes, there are other questions on the shortest distance between any 2 points on the parallel of latitude or distance along the great circle of any 2 points on the parallel of latitude. Below is a sketch of how the problem looks like. So what this implies is that usually whenever 2 points lie on the parallel of latitude, the question is usually about determining the distance between A and B along the parallel of latitude. But most times that's not the questions like that are not only limited to getting or finding the distance between A and B along parallel of latitude when 2 points lie on the same parallel of latitude. Sometimes the question can be find the great circle between 2 points that are on the parallel of latitude. So this, when questions are asked, when questions like this, or when questions are asked that the distance between A and B should be determined when A and B lie on the same parallel of latitude, and the question says that you should determine the great circle route. That questions like that are solved by what the mediums that all the methods that we're going to use in this lesson. So this is what we mean by the great circle route on the parallel of latitude, because usually when 2 points are on the same parallel of latitude, we only use formula for distances along the parallel of latitude. We don't use the great circle formula. But when in a case where these 2 points are on the same parallel of latitude and the question wants us to solve the great circle routes, we use these lessons about how to do that. So questions like this, or this form of questions, are interwoven in the sense that the data given concerns mainly arc AB. So from what we have here, this is this circumference of the small circle, and this is the circumference of the great circle, the one that is measured from the equator AB. So the equator also has an arc, and then this is the circumference of the small circle, which is this part here. So this form of questions are interwoven in the sense that the data given concerns mainly arc AB through D, but candidates are required by the question to find out some facts on arc AB through C. This can be done in 2 ways, namely split method and B, direct formula method. So we can use 2 formulas to find the great circle that is on the parallel of latitude. So don't forget that formula for great circle simply tab and 360 degrees times 2 pi r, and that of small circle that lies on the parallel of latitude is equal to theta over 360 degrees times 2 pi r cos alpha. So I'm sure that you are familiar with those 2 formulas, but then this particular case, or this instance, is where the 2 points are on the parallel of latitude and we are asked to find the shortest distance possible. Whenever a question like the shortest distance between 2 points is referring to a great circle, or most times instead of saying the shortest distance, the question will say find the great circle. So what it implies is that the great circle that's lying between 2 points that are on the parallel of latitude. So in that case, we are not just going to use this formula, we are going to the lessons are going to the facts, the points, the procedures that you're going to learn in this lesson are what you're going to use to solve problems like this, where these 2 points are on the same line of latitude, yet the question wants to find a great circle route between those 2 points that are on the parallel of latitude. So 2 methods that are going to be treated in this lesson are one, split method, and B, direct formula method. So these are the 2 formulas or 2 methods that we're going to use to find the great circle that's lying between great circle of 2 points that are on the same parallel of latitude. But usually, if you are going to solve for great circle, the 2 points don't usually lie on the parallel of latitude. Either they lie on the equator or they lie on the same line of longitude. But this peculiar case, they are lying on the parallel of latitude, and you have to look for the great circle route or the shortest distance possible. So in that way, we're going to make use of either split method A or B, direct formula method. So let's take examples. So P and Q are 2 points on latitude 55 degrees north, and their longitudes are 33 degrees west and 23 degrees east respectively. Calculate the distance between P and Q measured along the parallel of latitude, the great circle. That's the solution. P and Q are 2 points on latitude 55 degrees north. And their longitudes are 33 degrees west. And 23 degrees east. So this point P, this point Q. So obviously, P and Q are lying on the parallel of latitude. Okay, so PQ 33 degrees, 23 degrees. The angular difference theta, that's theta. The angular difference is theta. So E. The angular difference in longitude angular difference in longitude, that is theta, is equal to 33 degrees plus 23 degrees, and that will give us 56 degrees. So distance PQ, distance PQ along parallel of latitude 55 degrees north is equal to theta over 360 degrees times 2 pi r cos alpha. So theta is 56 degrees over 360 degrees times 2. We're not giving value for pi, so we're going to use the arbitrary value, which is 22 over 7, and the radius of the earth is 6,400 times cos 55 degrees. So 56 times 2 times 22 times 6,400 times cos 55 9045,070.97 divided by 360 degrees times 7, 2520, 3589.31 kilometers approximately. To the nearest two significant figures, 3,600 kilometers to two significant figures. B. So this is great circle. Now usually you see that these 2 points are on the line of latitude, and we're expected to find a great circle. So that means we're going to bring it to the equator. So this is what we're going to have. Now because this case is peculiar, different from cases where we usually find the distance between 2 points that are on great circle, which is they must either be on the equator or on the same line of longitude. So this particular instance is peculiar. We're not going to use that formula for great circle, which is theta over 360 degrees times 2 pi r. But in this case, we're going to make use of one of two formulas, but I'm going to use the two formulas in this example. Then subsequently, I'm going to make a choice between either the first formula or the second formula. Both formulas will give you the same answer, so you're not expected to use both formulas in an exam condition. But for illustration purpose, I'm going to show the two formulas or use the two formulas in this particular example. Then subsequently, I'm going to be using one of the two formulas. Alright, so now to get a great formula, we're going to draw 2 points here. I'm going to have this. Okay, so this is for the small circle PQ. So this is a small circle. We do have this. Okay, PQ. This the center of the small circle. Let's say C. So this is C, and then P, Q. So let's say it's X. Alright, so let's call it figure 1. And then this as a little small. The center of the great circle is O. The center of the great circle is O, while the center of the small circle is C. So this C, and here is O, P, Q. And then this is X as well. This is the right angle triangle. And then here is alpha. Okay. And okay. So let's call this figure 2. Okay. Figure 1. And from figure 1, the length of chord P, length of chord PQ is equal to, the length of chord PQ is equal to 2r sine theta over 2. Remember that this perpendicular divides this angle, which is the angular difference, which is 56 degrees here, because this is the small circle, and the difference in the longitude is equal to 56 degrees. So this perpendicular divides the angle into 2 equal parts, and also divides the chord into 2 equal parts. So half of it is xq, but we need the total length, which is pq. So also get that, we use the formula to be used but R is equal to, but R is equal to, no, but R is equal to R cos alpha. So the formula becomes 2R cos alpha sine theta over 2. So 2 times 6,400 times cos 55 degrees times sine. 56 divided by 2 will give us, so okay, let me just put 56 degrees divided by 2. So 2 times 6,400 times cos 55 degrees times 56 divided by 2 will give us 28 sine 28 degrees. So 2 times 6,400 times, let's get the value of cos 55. Cos 55 degrees 0.5726, 0.5726, sine 28 0.4695, 0.4695. So let's multiply them together. 2 times 6,400 times 0.5726 times 0.4695, 3447.11 kilometers, approximately 3,447 kilometers to the nearest kilometers. Okay, so that's the value for the length of chord. So let's come to, so from figure 2, we're going to get, we need to get this angle, because now we want to get the arc PQ, value of arc PQ, which is the great circle distance between P and Q on the great circle, and the great circle is measured from the equator, and we are getting the great distance between P and Q on the great circle from the parallel of latitude. So it's related to arc PQ from the small circle. Alright, so from the small circle, already gotten the length of the chord. Now from the great circle, for us to be able to do that, remember distance PQ as the great circle is equal to 2 alpha. Why? Because the total distance between P and Q from the equator, the total angular difference between P and Q from the equator is 2 times alpha. Alpha is simply the angle from here, from this part of the line to this perpendicular height, or this line that divides this arc into 2 equal parts. So this chord into 2 equal parts. So this angle plus this angle give us the total angle from this line to this line. So 2 alpha divided by 2 is 60 degrees times 2 pi r. That's the distance between, that's the formula to be used to get the great circle distance. But we need to get alpha. So for us to get alpha, we're going to use using sine ratio. Sine alpha is equal to xq, which is the opposite over hypotenuse. Using sine ratio in triangle, let me say in triangle OXQ, in triangle OXQ, sine alpha is equal to xq over r. But xq is half of the total length of chord PQ. So we're going to say sine alpha is equal to half the total length of the chord is PQ, but where SQ is just half of it. So to get half of the value, to get XQ, we're going to divide the total length by 2. And total length in this case is 3447.11 over 6,400. So sine alpha is equal to 3447.11 divided by 2. So this gives us 1723. 1722.55 divided by 6,400. So sine alpha is equal to, divided by 6400, that's 0.2693. 0.2693. That's sine alpha. Sine alpha is equal to or rather, okay, sine alpha equal 0.2690. So alpha is equal to arc sine 0.2692. So alpha is equal to shift sine 0.2693, 15.62 degrees. Now that we've gotten the value of alpha, we can substitute the value into the formula. So therefore, distance PQ, so distance PQ is equal to 2 alpha over 360 degrees times 2 pi r, and this will give us 2 times alpha is 15.62 degrees, and all divided by 360 degrees times 2 times 22 over 7 times 6,400, and we're going to have 2 times 15.62 times 2 times 15.62 times 2 times 22 times 6,400. That's 8797184 divided by 2520. Divided by 2520, 3490.95 kilometers approximately. Give us 3490 kilometers to two significant figures. That's 3,490 kilometers to two significant figures. So the great circle route is equal to 3,490 kilometers to two significant figures. So this is the final answer. So in essence, we had to split the information we have here into two parts. The first part is the small circle arc PQ, and the other part is the great circle arc PQ. So from the small circle arc PQ, we're able to get the length of chord. Then with that information available, we got to figure 2, which was the arc for the great circle, and then from there we got the angle or the angular difference from using sine ratio, which is sine alpha equals to xq over r, where sq is half of the total length pq, and why that was important, and how we got sq or the total length pq was from the arc from the small circle, arc pq from small circle, where we got the length of the chord pq. Now and from there, rather, we were able to get, once we got the value of alpha, we got the total angular difference in longitude, total angular difference in total angular difference rather, and then we substituted into the formula for PQ, which is the distance between 2 points on great circle, which is 2 alpha times 360 degrees times 2 pi r, and because because the distance 3,490 kilometers, which represents the distance between PQ on the great circle. So this formula is called split method. So we're going to go right into the other formula, which is called the direct formula method. This is the direct formula method. Distance PQ along great circle is equal to 2 arc sine cos alpha sine theta over 2 times 2 pi r over 360 degrees. So all you need to do is to be able to memorize this formula or know the formula, and then substitute into the appropriate variables, and then get your answer. So here 2 arc sine cos alpha is cos 55 degrees. Alpha is the parallel of latitude, line of parallel of latitude 55 degrees, times sine theta over 2. Theta is the angular difference between the two the angular difference between the PQ on the parallel of latitude, which is 56 degrees, and that gives us half of it is 28 sine 28 degrees times 2 times 22 times 6,400 over 360 degrees times 7. 3 sevens from 22 over 7. So I'm not sure, we don't need this information anymore, so let me wipe it out. 2 arc sine cos 55 degrees is 0.57 36 times sine 28 0.4695 times 2 times 22 2 times 22 times 6,400 281 600 and 260 times 7 gives us 2520. So let's multiply these two together. This will give us 2 arc sine 0.57 36 times 0.4695 is 0.2693 times 281,600 divided by 2520. So 2, this will give us 2 arc sine. So let's evaluate arc sine 0.2693. Arc sine 0.2693 26 15.62 degrees times 2 8.600 divided by 2520, and then this will give us, so we'll come here, so 2 times 15.62 2 times 15.62 is equal to 31.24 so this will be equal to 31.24 times 281,600 divided by 2520, and that is equal to 31. So 31.24 times 6,400, that's 199.36 divided by 2520. That's equal to 2 times 31.62, 2 times 15.62, that's equal to 31.24 times 281,600 divided by 2520. That's 3490.95 kilometers, approximately 3490 kilometers. So three significant figures, 1 to 2 significant figures. So compare this result to this result, 3490.95, 3490.95, and approximately 3,490 kilometers to 3 significant figures. So both methods will give you the same answer. However, you're not expected to use both methods in an examination condition. Either you use the direct formula method or you use the split method. So it's only in this example that, in this video, it's only in this example I'm going to use the two methods. I use the two methods to illustrate the two possible ways you can get the distance between 2 points that are on parallel of latitude, but the great circle route. Subsequent examples are going to use either the split method only or the formula method only. P is a town on longitude 74 degrees 42 minutes east, and Q is another town on longitude 20 degrees 18 minutes west. Both towns are on latitude 48 degrees 50 minutes north. Calculate any distance between P and Q measured along their common latitude. B. The length of chord PQ. C. The angle subtended by PQ at the center of the Earth. That's the solution. So in the diagram. Okay, so P is a town on longitude 74, 32, 74 degrees. Longitude 74. Okay, so note that 60 minutes equals to 1 degrees. So we're going to convert. So convert 42 minutes to degrees. So we're going to divide. So let me just do it here. So 60 minutes. Let's convert minutes to degrees. So if 60 minutes equal to 1 degree, therefore 42 minutes is equal to x degrees cross multiply 60x equal to 42 times 1, 42. So x equal to 42 divided by 60. 2 divided by 60 is equal to 0.7 degrees. So you can add 0.7 degrees to 74. You're going to have 74.7 degrees. So this one is 74.7 degrees. Next one is latitude 48 degrees. 48 point something. We're going to do here 50 divided by 60 is equal to 50 divided by 660, 0.8, 48.8 degrees. So this points P. So Q is 20 degrees 18 minutes west. So this will give us longitude 18.20 rather, longitude 20.18 divided by 60. 18 divided by 60, 0.3, 20.3 degrees west. Just point Q. And this is lying on the parallel latitude. Okay, so now let's proceed. So A says the distance between P and Q measured along their common latitude. So E, angular difference in longitude versus theta is equal to Q, P, center of the small circle is C. So this is 74. Q is 20.0 degrees west. 20.0 degrees, and P is 74.7 degrees. So 20 degrees plus 74.7 degrees, 95 degrees. The distance since PQ along the parallel of latitude 48 degrees is equal to theta 60 degrees times 2 pi r equals alpha. So theta is 95 degrees. 95 degrees is 60 degrees times 2 times 22 times pi 3.142 times 6,400 times cos 48.8 degrees, and that will give us 95 times 2 times 3.142 times 6,400 times cos 48.8. That's 2516636.377 over 2, actually 60 degrees. So divided by 360, that's 6990, 6990.66 kilometers. So the answer is correct. So 690 kilometers to two significant figures. Okay. The length of chord PQ. Length of chord PQ is equal to 2R sine theta over 2, which is equal to 2R cos alpha sine theta over 2, 2 times 6,400 times cos 48.8 degrees times sine 95, and that difference is 95, sine 95 degrees over 2, 2 times 6,400 times cos 48.8 degrees times sine 95 divided by 2, 47.5 degrees. So 2 times 6,400 times cos 48, cos 48.8, 0.6587 times sine 47.5 times 0.73773. That will give us 2 times 6,400 times 0.6587 times 0.7373, 6216.44 kilometers, approximately 6,220 kilometers to three significant figures. So C says the angle subtended by PQ at the center of the Earth. And do like this. Alright. So the angle subtended by PQ at the center of the Earth. The center of the Earth is 2 alpha, and this will give us there's alpha. So let's see this arc PQ, Q, and then we score your X. So if this from this line to the perpendicular line or perpendicular height is alpha, therefore the angle subtended at the center will be 2 alpha. 2 alpha, and here is the radius of the Earth. So to get angle 2 alpha, you see, but using using sine ratio, um, sine alpha is equal to xp, which is sine alpha is half the length of, okay, that's xp over r. Sine alpha is equal to xp is half the length of pq, half pq, and pq is the chord of which the length is 626.44 over r. So sine alpha is equal to half 6216.44 divided by 6400. That will give us 6216.44 divided by 2, 3108.22, 3108.22 divided by 6400. The sine alpha is equal to 3108.22 divided by 6400 by 0.4857 sine alpha, and alpha is equal to arc sine 0.4857. Alpha is equal to 0.4857, 29.06 degrees. But remember, the angle subtended by PQ at the center of the Earth is 2 alpha. But 2 alpha is equal to 2 times 29.06 degrees. That will give us 2 times 29.06, 58.12, 3.20 degrees. Therefore, the angle subtended by PQ at the center of the Earth is 58.12 degrees. 2 points x 32 degrees south, 86 degrees west, and y 32 degrees south, 14 degrees west are on the Earth's surface. Calculate correct totally significant figures. The length of chord xy, distance between x and y along the parallel of latitude to grid circle. So x is 32 degrees south, latitude 32 degrees south, 86 degrees west, longitude 86 degrees west. This point x. Y is 32 degrees south, 14 degrees west. Longitude 14 degrees west. Y. The center of this small circle C. Right, so E says the length of chord xy. Length of chord xy is equal to 2r sine theta over 2, which is equal to 2r cos alpha, sine theta over 2. For theta is equal to angular difference in longitude, and is equal to 86 degrees minus 14 degrees. 86 minus 14, 72 times 2 degrees. So length of chord PQ is equal to 2 times 6,400 times cos 32 degrees times sine 72 degrees divided by 2. 2 times 6,400 times cos 32 degrees times sine 36 degrees. 72 divided by 2 is 36. And 2 times 6,400 cos 32. 0.8480 times sine 36. 0.5878. 0.5878. 2 times 6,400 times 0.8480 times 0.5878. 63 80. Made a mistake. 2 times 6,400 times 0.8480 times 0.5878. 6380.2 kilometers, approximately 6,400 kilometers. Oh, correct. So 3 significant figures. So 1, 2, 3, 6,208 kilometers to 3 significant figures. The distance PQ along the parallel of latitude 32 degrees south. 32 degrees south is equal to 6,463 degrees times 2 pi r cos alpha. So the theta is angular difference in longitude, which is 72 degrees. 72 degrees divided by 2 is 60 degrees times 2. Pi is 3.142. 3.142 times 6,400 times cos 32 degrees. So 360 divided by 72. 5. Down to here 1, to here 5. So 2 times 3.142 times 6,400 times cos 32 degrees equal to 24106.46 divided by 5. So divided by 5, 6821, 6821.29, 34106.46 divided by 5. That's 29 kilometers. So approximately 1, 2, 3, 6,820 kilometers to 3 significant figures. Then B2, great circle, distance PQ along great circle is equal to 2 arc sine cos alpha sine theta over 2 times 2 pi r over 360 degrees. 2 arc sine cos 32 degrees sine 72 degrees divided by 2 times 2 times 3.142 times 6,400 divided by 360 degrees. 2 arc sine cos 32 degrees and sine cos 32 degrees times sine 36 degrees times 2 times 3.142 times 6,400 for 2 times 3.142 times 6,400 40 times 4021,217.6 divided by 060 degrees. The 2 arc sine cos 32 times cos 32 0.8480 times sine 36 0.5878 0.5878 times 40217.6 divided by 360 degrees. 2 arc sine 0.8480 times 0.5878 0.49885 times 4402 and 40 times 40217.6 divided by 360 degrees. So let's get arc sine 0.2 arc sine 0.4985 2 times 29.90 degrees times 40217.6 divided by 360 degrees. So 2 times 29 times 40217.6 that's 240,501.2.48 divided by 260 degrees. That will be equal to divided by 260 606,680.59 kilometers, approximately 6680 kilometers to 3 significant figures. So that's the answer for the great circle. If two places P and Q are on the same parallel of latitude 30 degrees north and they differ in longitude by 45 degrees, calculate the distance between P and Q measured along the parallel of latitude. Two angles subtended at the center of the Earth by PQ, shortest distance between P and Q. So P and Q are on the same parallel of latitude 30 degrees north. Latitude 30 degrees north. 30 degrees north. And they differ in longitude by 45 degrees. So we're not told whether if the okay. Okay, and they define longitude by 45 degrees. You don't know whether the two sides are on the same side of the globe or different sides, so just sketch. Let's just assume the center. Okay, so the difference in longitude, let's call this P and Q. P, Q. So this is P and this is Q. So the difference in longitude is 45 degrees. That's the angular difference. So A, number figure 1, the distance PQ, parallel of latitude 30 degrees north, project theta 360 degrees times 2 pi cos alpha. The angular difference is 45 degrees. 60 degrees times 2 times 22 over 7 times 6,400 times cos 30 degrees. So 9 here is 5, 9 here is 40. 5 here 1, 5 here 8, and 2 here 1, 2 here 4, 2 here is 11, 2 here 2. 11 times 6,400 times cos 30, 60968 point 0.19. 2 times 7, 14. So 60968.19 divided by 14. 4534.87 kilometers. 0.87 kilometers approximately. So 1, 2, 3, 4,000, 1, 2, 4,500 kilometers to two significant figures. Then 2, the angle subtended at the center of the Earth by PQ. So center of the Earth, that will be the center of the Earth O. So the angle subtended at the center of the Earth by PQ. So, this will give us 2. Alpha P, let's say O, E, E, Q. Alright, so the angle subtended at the center of the Earth, PQ is equal to POQ, P angle OQ, that's equal to 2 alpha. So put 2 alpha is equal to 2 arc sine cos alpha sine theta over 2. where alpha is the common where alpha is equal to the common parallel of latitude, and theta is equal to the angular difference So 2 alpha is equal to 2 arc sine cos 32 degrees, cos 30 degrees sine. Angular difference is 45 degrees, sine 45 degrees over 2 arc sine cos 30 degrees times sine 45 divided by 2, 22.5 degrees. 2 arc sine cos 30 0.8660 times sine 22.5 0.3827. 2 arc sine 0.8660 times 0.3827 0.3314. 2 arc sine arc sine 0.3314, 19.35 degrees. 2 times 19.35, 38.7 degrees. Therefore, the angle subtended at the center of the Earth by arc PQ is equal to 38.7 degrees. Shortest distance between P and Q is equal to 2 arc sine cos alpha sine theta over 2 times 2 pi r minus 2 pi r over 360. That will give us 2 arc sine cos 30 degrees sine 45 degrees over 2 times 2 times 22 times 6,400 over 360 degrees times 7. Everything here, 2 sine cos 30 times 2 arc sine cos 30 degrees sine 45 degrees over 2 is what we have done here. And the value is 38.7 degrees, so I'm just going to put it here. So it's equal to 38.7 degrees times 2 times 22 times 6,400 over 360 degrees times 7 is equal to 10,897920. 360 times 7, 2520. So 10,897927 divided by 2520, 4, 3, 24.57, approximately 4,300 kilometers to reach significant figures. So the shortest distance between P and Q is 4,200 kilometers to reach significant figures.